movement of the limb is associated with the maintenance of posture. Now let us see what is that. What is posture? Posture is defined as the attitude assumed by the body either with the support during the course of muscular activity or as a result of a coordinated action during the muscle activity to maintain the stability. Very simplified definition of the posture. It is a coordinated movement and it is support provided during the course of the muscle activity or even when there is no muscle activity, also to maintain the proper stability. In a little more complex words, posture is essentially the relative position of various parts of the body with respect to one another. There are three components there. I will read. One is that is with respect to one another egocentric. With respect to the environment, it is exocentric. With respect to the gravity, geocentric. So the posture is essentially relative position of various parts of the body, egocentric, exocentric, and geocentric coordinate systems. So that is a more complex definition. The first definition is a very simple one. It's an attitude assumed by the body to support during the course of muscle activity or the coordinated action that is required by a group of muscles to maintain the stance or the stability. Once having been seen the definition of the posture, what is the purpose of the posture? Say, for example, the orientation of the body part can be described in terms of these frameworks. The example, knowing the position of the head relative to the environment, that is exocentric and egocentric, that is to be positioned with the help of the visual system. And while knowing its position relative to the rest of the body, it is important to maintain the erect posture. So maintain the particular attitude or particular balancing situation. A geocentric regulation of the posture with respect of the gravity, that is geocentric, is important while you are performing certain actions to maintain the postural equilibrium. And this is defined as the state in which all forces acting on the body are balanced. So that means when you're talking about the posture in respect to the gravity, so all forces acting on the body are balanced in such a way that the intended position, the body rests in an intended position, that is a static equilibrium. We all have that static equilibrium. Certain point, now you are sitting on your chair and you have the static equilibrium, or this static equilibrium is disturbed when you progress with an intended movement and this progression without losing the balance. That means you don't fall or you don't sway or you don't injure yourself. So that means there are two components there, a static equilibrium and a dynamic equilibrium. That is about the posture. Now, I have just mentioned here, static posture, how you hold when you are not moving, that is a static posture. Like when you are sitting, standing, sleeping, resting on the table or bed, body segments are aligned and maintained in fixed positions. Static posture is usually achieved by the coordination and interaction of a various group of muscles, and they are not doing any movement or action. And it is just to maintain or counteract the gravity and other forces acting on our body to maintain the static posture. Then there is a dynamic posture. Dynamic posture, that is how you hold yourself when you are doing some actions. Just like When you are walking, you have to hold your body posture. That means walking is not a static. That is every moment there is a change in the position, the either upper limb position or the lower limb position. The limb positions change, the other gravitational changes are happening, the center of gravity is changing. So that means walking is you have to maintain the posture. That is a dynamic posture. Or running is a little faster than the walking in terms of the bodily positions. Or to you are bending over to pick up something, so that is also a sort of a change, because you don't want to fall down and you bend and you just take a pen which has fallen down. It is usually required to form efficient basis of movement. This is very much essential for our proper movement. The muscles and the non-contractile structures. The muscles, non-contractile structures are the ligaments, the bones, and the other aspects have to work. That means joints, ligaments, and the fascia and muscles are to work and adapt to the changing circumstances. That is with a dynamic posture. So that means we have now examined the static posture, just being in one state without any movement, dynamic posture with some movement, and this movement may be anything which we perform. What are the goals of the posture? The goals of the posture is to prepare oneself for attain a particular stance, or when you are trying to make any actions, the dynamic component, that the goals is to maintain the posture, shaping of the body for display purposes, as in dance. You just see the dance. Dance is a highly dynamic muscle activity in which the posture is has to be perfectly maintained. Otherwise, the dancer will fall down. That's one aspect. Or a gymnast walking on a beam, or a gymnast trying to pass through something. So maintenance of balance without losing the this thing. That means that's again another important event which we are all performing. Though we may not be a gymnast or we may not be a dancer, but we are real life gymnast and real life dancers. And while doing these actions, there should be the energy balance, because we don't want to spend the more energy for just maintaining the posture. Otherwise, you will not be able to perform your actions. Just a brief idea about the posture in humans. Our posture have two different complexities which we have adopted in the evolution. One we have adopted from the large mammal, the elephant, and the small mammal, the mice. Just to give an example, elephant, when it is standing, instead of flexing the knees, it is to spring forward, it will just stand rigid, crossing and cross the legs and one another and stand like a rigid structure. Similarly, when we stand, we just stand erect. The knees are extended because knees are not flexed and they are pillar-like. So they give a static, structural, pillar-like support by the anti-gravity muscles, and they are supportive to the body. On the other hand, like small animals are always on the move, or always, or if you have observed a rat, so are always trying to run away or escape. So in that situation, we also support some flexion attitude. So that means the weight supporting limbs in preparation for a possible or potential movement, as if we were ready to run. So that means we have adopted, we have two types of these things. One, our knee joints are flexed or extended, pillar-like, The other joints supporting limbs, other joints are flexion mode so that we are prepared to run. So that is the second component. That is what the human or Homo sapiens have evolved. How the posture is maintained and regulated. The posture is maintained by series of reflexes or the reflex actions, and these reflex actions are centered in the spinal cord, medulla, midbrain, and the cerebral cortex. And these reflex actions come at the segmental level or come at the medullary level, or they are integrated at the midbrain level, or they are integrated at the cerebral cortical level. That means 4 levels of integration for maintaining the posture. Now, in the one segmental level, the most of them are concentrated in the spinal cord or the brainstem for the cranial nerves. So these reflexes are stretch reflex, crossed extensor reflex, the positive support reaction, negative support reactions. They are all centered in the spinal cord. I will explain each one of them in the subsequent slides. Similarly, there are tonic reflexes. That means continuously they are active. These tonic reflexes are generated from the neck muscles or from the otolith organs present in the vestibular labyrinth. That means those organs which try to receive or which try to sense the gravity. That means these are tonic labyrinthine reflexes. These are tonic neck reflex and tonic labyrinthine, they have the center in the medulla. Then we have another series of reflexes which are regulated in the midbrain. Midbrain is the center for this. These are called righting reflexes. Righting means the orientation of the body in space in relation to neck. The righting reflexes is the orientation of the body in relation to space and its parts. Now we have these righting reflexes. There are series of righting reflexes. So these righting reflexes are a neck righting reflex, labyrinthine righting reflexes, body righting reflexes, limb righting reflexes, and optical righting reflexes. So these righting reflexes, the neck, labyrinthine, and body righting reflexes are located in midbrain, and the optic righting reflexes is present in the cerebral cortex. Let us see the segmental reflexes. What are the segmental reflexes which support the body posture? The first is the stretch reflex. Stretch reflex provides the muscle tone. Muscle tone will give the partial state of contraction. Partial state of contraction, especially those posture regulating muscles, they are remaining in a contracted state, and that would be necessary to provide a rigid pillar-like structure. So now, what is the stretch reflexes? This is stimuli is the stretch because of the positioning, because of the whatever the action you are trying to do. The intrafusal response is the muscle contraction, the receptor is the intrafusal fiber, and afferents are 1A afferents. Then center is in the spinal cord, the efferent is in the alpha motor neuron and the muscles. So mostly these stretch reflexes are extensor group of muscles, because to provide you the rigid pillar-like structure, you need to have those extensor group of muscles rigid or contracted. So that means the extensor group of muscles, these are called the weight bearing or the supporting muscles. supporting muscles. The flexors are not supporting, they give away. The extensor gives the what is the rigidity or the strength, pillar like strength for a support of the body, stance or the posture. Crossed extensor reflex. So if I go back here, this is the stretch reflex. I have just shown, I have explained this thing wherein there is a stretch of the muscle. The stretch of the muscle will elongate or increase the length of the muscle spindle. And if it is increased, there is an increased activity in the 1A afferent. And this 1A afferent will have the monosynaptic contact with alpha motor neuron. This is alpha motor neuron there. And this monosynaptic contact in turn produce the extrafusal contraction of the same muscle. So that would produce the contraction, that is the stretch reflex. Now, then at the same time, through an interneuron, it will activate the antagonist group of muscle. Suppose if this is an extensor group of muscle, the flexor group of muscles so are inhibited so that this muscle contracts. So this has started with a stretch, and the stretch is prevented. So that is how the stretch reflex is operating. I have written down the details here. I think I have already shared this thing, and again I will share with you one more time. Now, going back, so I talked about the stretch reflex. There is a muscle contraction. The center is in the spinal cord. Then we will go to the crossed extensor reflex. This also I explained in the muscle reflexes. Now we start with here. What's happening there? The bottle is broken, and the broken bottle, that is he is getting hurt. He's getting hurt here, and these painful sensations, they reach the spinal cord. Okay, and of course, these fibers, they go to the lateral spinothalamic tract, and they go up for the pain sensation. No, that's a different aspect. A collaterals reach the interneuron. The collaterals reach the interneuron. So the muscle is activated here. This is producing extensor muscle contraction on the opposite side, on the contralateral side. So this limb becomes like a pillar, like a rigid structure. So this is a crossed extensor reflex. Already I have told, and it is a part of the withdrawal reflex, and it is part of the supportive response. It is a part of the actions taken by the muscle. So that means we have the crossed extensor reflex. Now, where were we? We just saw the segmental reflexes. The segmental reflexes, one we studied the stretch reflex, and crossed extensor reflex, that means the flexion of the limb. That means it is a stretch, or the maybe stimuli, it may not be stretch, it may be because of the injury. Both stretch of the extensor group of muscles or flexion of the limb. If stretch of the extensor group of muscles and the flexion of the limb with extension of the opposite side. And here is the proprioceptor which is acting. That means the proprioceptor, the muscles and joints, they are activating. The response is the spinal cord. So that means both the stretch reflex and the extensor, crossed extensor reflex, they work together. They will try to provide a structural basis for the thing. Then we have another important thing, positive support reaction and a negative support reaction. And positive support reaction, that means contact with the sole. What happens? The foot becomes, suppose if some of the animals or even the child or the infant touches the top of the table, it will extend and it will like provide like a pillar like structure. And here, because of the proprioceptors or the 1 beta touch receptors and the fascinia and corpuscles, they are carried and in the distal muscles, and they will be just producing a rigid stance like. And this is because of the extensor, because the proprioceptors are present in the flexor here. So that means that will provide the extensor muscle activity. And here in case of the stretch reflex, there will be negative supporting reaction. This is because of the proprioceptors of the extensor, and that would take away. This is called a magnet, and this is giving away. Now let us see that positive support reaction. Which one positive supporting? Just see here what's happening. Trying to hold, okay, making it, and here touching the edge here, so it becomes rigid. And this is the positive support reaction. Maybe I will move it further. This positive supporting reactions, it's also known as a magnet reaction. The magnet reaction means the pressure on the pads or the fingers or the toes, and then that would or a dorsiflexion of the hand. These are the stimuli. The afferents are from the skin and muscle. The effect is hand and foot are extended, rigid, like support the body. Limbs become solid as rigid pillars, and by this, especially quadrupeds can be made to stand up for at least 2 to 3 minutes. But even in human infants, we can see particular action there. So now this is the positive supporting reaction. It touching and it is giving, and I am giving a negative. So because it cannot hold on to this thing, and it withdraws, because already this leg is this thing that is providing the negative supporting reaction. That means that withdraws, that gives away the stimulus, because there is a stretch here, and once there is a stretch, that stretch of the extensors and the spinal cord and release the positive supporting reaction, the limb no longer supports the body weight. So this is the limb which is a negative supporting reaction. So that means we have a positive supporting response, and positive supporting response is here, that is a step reflex, and a negative supporting response is here, withdrawn from the site. These are segmental reflexes. They are operated in the spinal cord. So to go back here, now we have stretch reflex, cross extensor reflex, positive supporting reaction, the magnet reaction, and the negative support reaction. And they are all having the center in the spinal cord. And these are the receptors. These are the responses. These tonic reflexes, they either originate from the neck muscles, or they originate from the labyrinthine or the otolith organ. So these otolith organs, because they try to sense the gravity, utricle and saccule in the vestibular system. We have the 3 pairs of semicircular canals. They are for the balance or the sideward movements, and the utricle and saccules are for the gravity. These are called otolith organs. The specialty of the otolith organs is that there is a mucus on which there is a autoconia. That means a dust, calcium dust is there, and this calcium dust is having sitting on the hair cells, that would provide the stimulus. If there is a gravitational pull upward or downward, the traction on the hair cells is altered. So that is where how the gravity works on the otolith organs. Now in the otolith organs, one is in the horizontal plane, one is in the vertical plane. So that vertical plane is easily sense the gravitational pull up or down. The horizontal scale will see the linear acceleration. So that means we have two of these. Utricle is in the horizontal plane, saccule is slightly inclined, and it is in the upward, so that would take up the gravity. One is taking up the linear acceleration, one is taking up the gravitational acceleration. Now coming back here, there are what are called tonic neck reflexes. Now when I will come back to this thing, and if you see this, this is one of the baby. I have just the head is moved this this side. What do you see? This side, this is jaw. What happens to this limb? This is extended. What happened to this limb? This is extended. So jaw limbs, there is a extension. So the limbs towards the jaw, this is extended. Limbs towards the skull, this is skull. Limbs towards the skull, what is happening here? There is a flexion. So jaw limbs extend and the skull limbs flex. I'm making a very simple statement. So that means this is the response. Response when you turn the head on this side. When you turn the head on this side, this response is achieved by the proprioceptors present in the neck muscles. The proprioceptors present in the sternocleidomastoid and other muscles, they are reaching through the accessory nerve and to the medulla, and they will try to make these muscles extend and these muscles flex, because these are crossed. It is something like a crossed extensor reflex or a crossed reflex. Same graph. These are tonic neck reflexes. You can also see here, this is jaw limb. See the extension there. This is a skull limb. This is a flexion and a flexion. Okay, so now come back here. So now what happened? Head turned to one side. That will neck proprioceptors are activated, and the activation of the neck proprioceptors through the medullary centers extend the limbs on the jaw side and flex the limbs on the head side or the skull side. Now, suppose if the head is moved up, if it is the extended head, the neck is extended, the upward movement, then what happens? Now let us see how it looks like in the baby. This is head is turned here. Now if the head is turned here, how the baby is reacting? The head is extended. That means it is extended. The neck is extended. What has happened here? You just see the upper extremities, they are extended. See that? And lower limbs, the flex. Okay, so now you can, I just mentioned about head turned to side. When the head is turned to the side, you have the flexion on the skull side or the jaw side, and flexion from the skull side and the extension on the jaw side. But here, when it is moved, this upper extremity is extended, lower extremity is flexed. When the head is bent or it is coming flexed, you can just see the flexion. What is happening? So this is the position, as if the baby is passing through a hole. Baby is passing through a narrow space. Suppose if you were to enter into a cave, you will take this posture. So that means there is a flexion of the upper limb and extension of the lower limb. These are very primitive reflexes, and because of these primitive reflexes, the delivery is possible. Can you? That means the baby, the head presentation in utero, then when it is coming down, the flexion, that means head is presented, head is a little flexed, and the flexion makes this flexion, and it will pass through the birth canal easily. So as if we have to pass through the birth canal, and these are primitive reflexes, so that that particular things. So now I have mentioned here, up, forelegs extend, hind legs flex, down, forelegs flex, and head legs extended. These are called tonic neck reflexes. Tonic neck reflexes. So now we have studied 3 tonic neck reflexes. So when it is turned sideways, suppose if I just tilt the baby's neck that side, so that means these becomes extend and these becomes flexed. So something like that. So now you have these three patterns of tonic neck reflexes. They are originating from the proprioceptors present in the neck muscles and the joints, and these proprioceptors carry to the medulla and bring about the action on the muscles which they produce the action. Then we have another tonic reflexes. These are labyrinthine reflexes. I mentioned about labyrinthine reflexes. I spent a little time on the otolith organs there. So now I will come back with the otolith organs. Now we will look into the tonic labyrinthine reflex. Tonic labyrinthine reflex. You just see that. This is a tonic labyrinthine reflex. You just see in this case the backward movement of the head. The arms get extended. They get extended, and even the legs extend. So if this is the movement, because here the otolith organs are excited, and when the otolith organs are excited, because it is trying to hold the neck up, and in that situations the otolith or gravitational pull of the otolith organs that would make the extensor group of muscles to be activated, and that would produce the extension of the upper and lower extremities. You see that it is the baby, the figure you have seen from the infant. Now at the same time, so because this if there is a forward movement or the flexion, the flexion means the head is tilted downward. The head is tilted up, head is tilted down. So that means the movement, it is going against the gravity. In that case, these limbs, both the limbs, the upper limbs and the lower limbs, they get flexed. So these are called tonic labyrinthine reflexes. So whenever we are falling with a outstretched or a neck in that position, suddenly we will try to make this type of a stance. If this thing is flexed, and you will come up with this. So that may happen. You can just see when you are diving. Normally to attain such a thing is difficult. Attain a very nice diving, these things is not possible. You can imagine yourself, if you are going for a swimming and trying for a diving, so these reflexes become operative. These are tonic labyrinthine reflexes. Now here I have just mentioned, these are the strip I have taken. So again, tonic labyrinthine reflexes, these are coming from the gravity contraction of the extensors of the muscles, otolith organs, and the center is in the medulla. And the tonic neck reflexes, we have three components. When the head is turned to one side, when the head is turned to the upward or downward. So now change in the pattern of the extensors of the limbs on the side which the head is turned. And hind legs flex in case of upward movement, and the forelegs flex in case of a downwards. The neck proprioceptors and the otolith organs are the receptors, and the center is in the medulla. Now coming back with the another component, the writing reflexes. What are these writing reflexes? Writing reflexes are those reflexes which try to maintain our body posture in space. These writing reflexes are generated by 4 or 5 sets of a series of reflexes, 5 sets of reflexes operating. So of that, we have a labyrinthine writing reflexes. That is a tonic labyrinthine reflex. Now don't confuse that with this. This labyrinthine writing reflex, that is starting with the gravity and the writing of the head over the body. Writing of the head means the positioning of the head in relation to body. And the here the activation is coming from the gravitational pull or gravitational activity. The otolith organs are participating. The center is the center for this thing is in the midbrain, because it is located, or it is at the collicular or tectum level, wherein they try to maintain the visual, auditory, and the proprioceptive in other proprioceptive inputs. They all clubbed here. It's in the midbrain. The neck writing reflexes, that means the neck is trying to change. So now neck is trying to change the posture. It is the neck muscles which are coming up, and when these neck muscles are operative, and they will try to position the neck in relation to thorax, the trunk and the upper extremity. Of course the pelvis automatically comes along with the trunk or the thorax. Here the receptor is the muscle spindle or intrafusal fibers of the neck muscles. The center here, they will go up. These are proprioceptive inputs. They will go up into the through the cerebellum. They will go up in the collicular region, and they will have a interaction there in the tectum. And this is at the midbrain. The midbrain is the center. The body writing reflexes on body, body on body, body on head, body on neck. So that means neck writing, usually we can also classify the neck writing reflexes on the body, neck writing reflexes maybe on the head, and neck writing on the body and the extremities. So now the body writing reflexes, body on head. So that means the pressure on one side of the body tries to orient the head. These are exteroceptors. That means the pressure coming from the skin and the other receptors, they will sense the position of the body, where how I am, and I am trying to make it possible to orient. So these are body writing reflexes on the body and on head. So now similarly the body writing reflexes are trying to orient the body. So these are also same way. The center is in the midbrain. Okay, so now the limb writing reflexes, we have a lateral displacement of the limb while standing, so that try to hop, that will try to change. These are muscle spindles. The center goes a little higher up. These are called a placing reactions. We try to place ourselves. So whenever some limb we are touching, we try to place ourselves. That is the cerebral cortex. Then hopping, that means a sort of a jumping or the placing responses, that these are also having a lateral displacement, and they will be having a center in the cerebral cortex. Another important writing reflexes which is coming from the visual cues. These are called visual writing reflexes or optic writing reflexes. These optic writing reflexes originated from the vision, and they will try to orient the entire head and the body and the neck, because we know we see things and we orient ourselves. That is the writing reflexes. So that means we have 5 labyrinthine writing reflexes, neck writing reflexes, body writing reflexes on body, and body writing reflexes on head, and then optic writing reflexes. These are placing reactions and hopping reactions. These are known as limb writing reflexes. Now, so this is a table I had taken from Genong. I want that you read this table today. Day after tomorrow, I will just again continue, because I will continue with the writing reflexes. Maybe I want to, because sometimes the writing reflexes may be a full question. I want to go little more detail with the writing reflexes with examples. I will come back to you on Friday with the writing reflexes. But this table gives you all the postural reflexes. Maybe when I post it, you can just see it and see it in the expanded mode or the zoomed mode in your mobile or laptop, and then try to see it. Whatever the detailed information I had given here, what is the reflex, what is the stimulus, what is the response, what is the receptor, where the center of these things. I'm not going into the again repeating these things, but I would certainly come back to you with the writing reflexes, because the writing reflexes you need a little more time to understand. Okay, so next class I will continue with the writing reflexes, and also I will continue with the CNS lesions. Okay, today.